Hi there, let's talk about using addition in order to subtract. So I want you to think for a second. Do you actually subtract when you see a problem like this, or are you actually adding? I don't know about you, but I never subtract. So if I were going to solve this, I would not use a subtraction strategy. My personal approach is to think to myself, well, what could I add to 75 to make 125? So this relationship, this connection between addition and subtraction is a really important one. But how do we teach it? So we don't want to begin with writing an expression on the board and just telling our students that we can actually just, ask ourselves, what can we add to 6 to make 10? We want to start in a more concrete phase where students actually get to work with materials. So in the concrete phase for this strategy, we want to really reinforce the idea of parts and wholes. So what do we have here? 5 and 5, so we have 10. Okay, so we could start, for example, with 10 base 10 blocks and get our students to break them up or separate them in different ways. So here I could separate them into 4 and 6. What happens when I join them back together? I have 10. Or I could separate them into 5 and 5, into 2 different parts of 5 and 5. And when I join them, I make a whole that equals 10. Okay, I could separate them into 2 different parts, a 2 and an 8. And again, I can join them back to make 10. Now this is basically a concrete representation of the part whole model. So if my whole is 10, I can show that as 2 parts of 5. Okay, so this is a concrete way to start making this connection. This is a representational way to start making this connection. Now, once we've provided a lot of opportunity to work with manipulatives and to work with other models such as part whole, that's when we can start actually writing equations. Okay, so now from this we can relay to our students that if we start with 10 and we take away one of those parts, we take away the 5, we are left with the other part, which is 5. However, if we join those parts back together, we will get our whole that is 10. So here we are really working with this relationship between addition and subtraction. The fact that we can separate a whole into 2 parts, or we can join those parts together to make the whole. Okay, so this strategy needs to begin with a ton of work with the part whole model, both in concrete and representational form, before we get to this phase. So too often we start with the abstract phase and we just kind of expect our students to have those connections already built, but we have to remember that they don't necessarily have these pictures in their heads yet, or the visuals that are going to help them make the necessary connections. So we need to start in the concrete phase, which is with manipulatives. And you might use beaded number lines or rec and recs, base 10 blocks, unifix cubes, bingo chips, anything that your kids can manipulate. Okay, and then this is the representational phase, a drawing such as this, or anything else that your kids come up with, any other drawn representation that represents their thinking. This is the abstract phase. And this is what we're looking to as a goal, but we're not going to rush to get here. We really want to build the understanding with concrete and representational activities first. So sometimes people start with concrete activities, maybe for a class or 2, then kind of incorporate a few representational activities, and then we rush along to the abstract. What I want to encourage you to do is to think of the CRE model like a Venn diagram and incorporate as much of that concrete, representational, and abstract thinking into each lesson or activity that you do as you possibly can. So imagine if when we are modeling a concept like this, maybe during a number talk or during small guided math groups or any other opportunity that you have, if we can model this in all different ways, just imagine the difference that it would make to your students' overall understanding. Okay, so once we've worked a lot with all these different models, then this notion that we can add in order to subtract becomes pretty simple, because here we're just trying to figure out the missing part, right? We had 10 as a whole. If 6 is in one part, what is that missing part? Okay, and now that your students have had the chance to make lots of connections and they have these visuals in their mind, this will be a lot easier concept to understand. So I hope you enjoyed this video. I hope it's useful for you. And if you would like information on other mental math strategies, please visit my website at shelleygrayteaching.com. Thanks so much. Have a great day.